So this next section we want to jump into is all about applications. Thank you for coming again, by the way. I appreciate that. Yeah, I was worried. You didn't move. Excellent. So we're going to talk about application security best practices. What we're going to cover is kind of some of the things that you can do on top of our platform, how you can actually think about that. Security, obviously there's some subtle differences in how you might think about security in a cloud environment, but a lot of the same things that you do today are going to apply in this environment as well. So we're going to sort of go through some of those, and then if there's time, I might be able to take some questions at the end. We'll hold those for the last little bit, though. Okay. So obviously, application security, just like it is anywhere, is something you need to think through. Has a lot of moving parts, has a lot of pieces. How you choose to secure data in transit, at rest, on disk. A lot of a fairly complex and deep process and problem. So there's a lot of things that go with it. We actually do have several white papers that you can take a look at. Again, at aws.amazon.com/whitepapers. You'll actually see fault-tolerant applications. There'll be a security white paper at aws.amazon.com/security. Sort of cover a lot of these topics in more depth. I don't think we can cover everything in application security in one 45-minute session, so we'll try and hit on some of the key points as we go through. But fundamentally, the one big takeaway is most of your traditional best practices still apply, right? The same things that you do today around securing data at rest, in transit, how you might apply encryption technologies, the choice of technologies you might use, the software packages that you might use in the environment. A lot of those same approaches are great, and they work in a virtualized environment just like they work in a physical data center. So it's definitely a sort of a key takeaway here. And there are ways that, obviously we can help in terms of how we manage our infrastructure, how we build out the environment, and the services that we provide or capabilities we provide under the covers and on the platform to make it a little bit easier to do certain things. Now, the fundamental thing that you want to take away from this whole discussion around security is that it's really built around a shared security model, right? So we manage and own the physical infrastructure. We obviously take care of the data centers. We take care of the the backplane that provisions virtual machines for you. We deal with the physical network. We obviously take care of the managing the employees that take care of this physical infrastructure. We deal with a virtualization layer. Those are all things that we take care of. But a lot of responsibility around building a secure application actually falls on the application developer's head. If you spin up an EC2 instance and leave port 22 open to the world and have a blank password for your admin, that was a poor choice. Can't help you there. There's a lot of things that you have to do in terms of your application, because from the operating system up, you're in charge. That's an important thing to really think about, is that at the virtualization layer, the management layer underneath, the physical network, the physical security, we're obviously taking care of that. But from the minute you get to that operating system, whether it be Linux or Windows or Open Solaris, what have you, whatever you're using, from that operating system up, you're in charge. You're the administrator on the box. You're in charge of locking the application down, locking the operating system down, and making the choices. You're still managing those instances and those nodes. So it is much more of a shared model. There is no magic pill here. You still got to obviously lock things down appropriately. So you own the operating system, the application. Setting up security groups, as we discussed in the earlier, for those of you that were in the architecting for the cloud session, there was a talk about layered security groups where you could only allow access from other machines and other security groups. Setting those up properly, configuring those in a way that makes sense for your application is your responsibility. We make them available to you to make it easy. If you want to do things like on the operating system on firewalls, you want to enable a Windows firewall, or you want to use something like IP tables in the Linux environment, you can go ahead and set up and configure those things, and that's in the operating system, so you own setting that up, right? Network configuration, who can talk to whom. If you're using virtual private cloud and you want to be managing subnets, allowing network ACLs between those subnets, again, that's something you set up. We give you the tools and the ability to manage that, but that's going to be your responsibility. And then, of course, account management. Who can access the infrastructure? Who can access the operating system? Who can access the application? Again, sort of your side. So we're giving you the flexibility of an infrastructure on demand to sort of create an environment that satisfies your business needs. But then, we're obviously going to manage the security around those layers. But then from the operating system up, you get control, which also comes with responsibility. Right? And of course, the same thing applies from a certifications perspective. So when you think about, you look on our security page, you'll see a lot of info about the various certifications that we have and maintain for the environment. But those apply to obviously the things that are within our control. So obviously we have things like a SAS 70 Type 2 audit. We have ISO 27001 certification. We have, PCI level 1 DSS certification. We on top of it with FISMA low and moderate with various partners managing that. We have ITAR for the GovCloud region. We have ITAR certifications, but that's at the infrastructure layer. Again, now if you're going to build an application on top of that infrastructure, and let's say you want to build a PCI level 1 compliant because you want to take credit card information, you're then responsible for the application layer, security choices that you make in terms of how you encrypt the data, how you encrypt it in transit on disk, how you transmit it securely between the various instances in the platform, right? And so we have a whole bunch of different certifications customers have achieved on top of our infrastructure based on being able to reference the AWS environment certifications we have. They've done SOX applications, HIPAA, FISMA, ITAR compliance scenarios. Those are all possible on top, but it requires obviously referencing what we've done at the infrastructure layer and then ensuring that you're in compliance with the software and application level rules that sort of are on top from a certifications perspective. Does that make sense? Now, the important thing to realize, and this is something I talked about before, but it's also a key point here, is resources and data are really in your control. You manage them, you place them, you start them, you stop them, you decide when they start and stop. If you use auto-scaling, obviously we make some choices for you, but you set the rules around auto-scaling. So really the way to think about this is that although it seems like there's this magical expanding, scaling infrastructure, you're making all those choices. You're setting it up and managing how you want it to run. You're owning that operating system. You're specifying what region and what availability zone a server might launch in. So if you want to be in the GovCloud region, you can specify, I want the GovCloud and I want availability zone A, right? You start that server will never move. It won't move out of that availability zone. It won't move out of that data center that it's part of, that availability zone, right? Same thing with your data you might put in S3. If you choose to put your S3 data in the US East region, it will never migrate outside of that region unless you explicitly choose to move that, right? So there's a lot of rules we put in place around how our infrastructure replicates and migrates things that actually help you ensure that things stay where they are and where you want them to be, right? Because obviously there's a lot of rules that apply to data, where it can go, who can see it, how you can deploy it and manage it, and we try and give you the tightest control possible to sort of place those things and launch them as you see fit. Yes?
In terms of disaster recovery, do we have to set up our disaster recovery zone as well, or is that something that's built right into?
So the question was in terms of DR, do we have to set up your own region? Yes, you would set up your own DR approach in your own region. So if you want to fail over from US West to US East or vice versa, you would then pre-position machine images in that new zone. You would replicate data, on a nightly basis to that new zone. So when a disaster does occur, you can spin up infrastructure in that other region. That would be something you would own. We would never do that automatically for you, just because we don't know whether that's okay for your data or your infrastructure to move between regions, right? Obviously, you manage the network access with security groups. Obviously, we have some tips there, using rules for controlling access between layers. The way I think about security groups from a networking perspective is a security group represents a role and the access that is needed for that role in part of your application. So a web server is a role, an app server could be a role, a database could be a role. One server or one instance could be a web app and DB server, and you would apply 3 security groups to that. But then the way you build your security groups is that it's around each role and ports and protocols necessary for that. And then what you can do is choose what roles are going to be running on a particular instance and then add the security groups that are necessary for that particular instance itself. But you can use multiple security groups on a single box, or you can spread them out as you see fit. But you control all that. You can also obviously restrict access from an IP range perspective. So in many cases, you may be talking, that's great between layers in the app, that the web can only talk to the app tier on a certain port, but what about from the outside? You control filtering the IP ranges that you want access from. And obviously, that's just from a pure network perspective. At the operating system and the application level, you can apply additional layers of security like SSH keys or client-side certificates for different types of access. Those are all things that you can apply on top on the operating system. The other thing is we also offer a whole identity and access management layer. And what this means is, let's say you have an account, and you have a team of developers and admins and that need to actually access and manage that environment for you. What you can do is create accounts for each individual, each individual employee underneath you that may have to manage that. The reason why that's important is that allows you to then have very fine-grained control either at the single account level or at the group level. So you can create a developers group and then Bob, Sally, and Jim are in the developers group, and there's an admins group, and Fred is in the admins group. Fred might be able to do, start and stop servers, attach drives, change security group settings. He might have total control, and you could give Fred distinct access. Whereas, your developers have a different level. They might only be able to start servers but not stop them. Attach drives, not detach them, right? Put things into an S3 bucket but not delete them, right? So you can restrict their access at an API level. And then when they go to use their set of credentials to access the AWS environment, they're limited in what they can actually do. It's obviously the other reason for this being useful is that, let's say Fred decides to move on, goes to a different group, organization, company. You can turn off Fred's account distinctly without actually impacting everyone else's ability to manage the infrastructure. So we've given you your own overlay to manage accounts underneath. On top of that, we have a feature called Secure Token Service that allows you to generate temporary tokens. So if you want, you can actually federate your own internal identities and use those as a way to generate a real-time identity for somebody to manage the infrastructure. So you could, through a web service tied into your Active Directory, go ahead and generate an identity for Fred for the next, say, 12 hours to be able to manage a piece of infrastructure. That token would expire. He could no longer call those APIs, and you've actually got a secure way to give him temporary access to something, right? So we have that layer for you. Yes? Yeah, so the question was, is there an integration with the corporate LDAP? You could build that. It's not by default built into anybody's LDAP platform or any Active Directory platform. There's actually a webinar on our website that shows an example of how to use an IIS web service and then use the group membership in Active Directory as a way to generate a token and actually even storing bits of policy in Active Directory. You could do the same exact thing with an LDAP server as well. So you'd have to build that integration, but it gives you the flexibility to leverage your 10,000 person LDAP server that you already have identities for, as opposed to using our identity system underneath the covers, right? And then, of course, with this, you can upload your own keys if you want to generate your own identities, and of course, we have multi-factor authentication as well. So if you want somebody to have a key fob to log into the console to manage resources, that's an option. There's a question back there. Right. So the question was that the private IPs can actually change, and this is in standard EC2 when you reboot a server, or not reboot, but stop and start. The private IP and the public IP can change on it, and setting up security groups can be complicated. I would recommend first looking at security groups that don't reference IPs, but rather other security groups, and that's great for inside the environment. From the outside, then what you would end up doing, because if it's from the outside, you would actually use either elastic IPs because you want static public IPs that you want to access, or you could actually filter to IP ranges as opposed to single IPs. But not a perfect solution, but it actually it can work for certain scenarios. So, and of course, a thing to note here is that we can't log in to your instances. I've actually gotten that question. Somebody asked me once, like, well, I lost my root password. Can you just log in and reset it for me? Like, no, you don't want me logging into your operating system, fundamentally for many reasons, but security is obviously the most important one. So for that reason, we can't log into your instances. So you do obviously manage everything from that operating system up. Question here?
Can you build access to the government's PIV system?
Yeah, so the question was, can you build access to the PIV system? I have to defer on that one. I probably need to learn a little bit more about the PIV system before I make a commitment to any answer on that front. I think that's a great conversation because I've heard a lot about that identity system, and I'd be curious to see what we could work out there. So maybe afterwards, not right after the session because I've got to run across the way, but at the end of the day we could talk about that. And obviously, protecting your data with encryption is key, right? So, this is something, obviously it depends on the security of your data set and how secure that data set needs to be, but, we provide some levels of built-in encryption. So, for example, anything you transmit to and from our APIs, we have SSL endpoints for, obviously, but things that you transmit between layers of your application, between your web and app tier, you may make a choice that you want to actually encrypt that data along the path. Obviously, using SSL or TLS works there. Obviously, the configuration of the security groups allows you to ensure that traffic going into those nodes is only from nodes you know and trust. So it may not be required for every scenario, but it's available to you at your application level. And then at rest, S3 just launched a new feature to enable server-side encryption. But if you want to do your own key management and how you encrypt that data, you could obviously encrypt that data before you store it as well. So you have kind of flexibility there. Either we hold the keys and encrypt it for you and rotate them, Or you'd say, no, I want to own the keys and manage the key rotation. So in that case, you'd pre-encrypt and store yourself.
What kind of encryption response with the hardware provided by
Yeah, so the question is what the type of encryption is. I'd have to refer to the documentation on that one. I haven't looked at that explicit feature in detail yet. So.
Well, the other thing about your encryption, do you have a FIPS 140-2 certificate for it, or have you tried to get one?
So the question was, do we have a FIPS 140-2 certificate for it? I don't know off the top of my head. I can look that up. Yeah. Yep. No, absolutely. So the alternative approach is obviously if we don't have that in our server-side encryption feature, then you just wouldn't use our server-side encryption feature and use your own encryption approach, which would be compliant with your needs, and then you would store it in an encrypted format, kind of thing. Additionally, obviously, on top of the that's obviously for S3. If you're looking at storing something in a database, you can either encrypt the records before you store them, which isn't great, obviously, for queryability, but certainly good for protection. Or you can actually then enable an encrypted file system. It's a fairly common approach. BitLocker for the Windows environment, TrueCrypt, DMCrypt SafeNet has a product that actually works on Windows as well. So several products out there to encrypt the entire data drive. So now whatever's stored on disk is actually encrypted at the actual at rest on the drive itself, either in backups or even when attached to a server. And then, of course, for folks that are looking for more sort of well-known networking approaches, obviously a lot of questions around security groups sort of harken back to our standard EC2 offering, but then, of course, we have a virtual private cloud, which is the same approach that you would take for setting up your network for the GovCloud product. And there, you can actually create multiple subnets. You can specify your IP ranges. You can manage that. You essentially get the ability to create your own overlay network. So you could have 10.1.0.0/16 is my data center. 10.2.0.0/16 is the cloud. And then those two environments can talk to each other as if they're on the same network, and you can specify subnets within the VPC product. You can control what the exact IP is of the machine when you launch it, so that it's predictable and well-known, and it stays the same between stops and starts. And then, of course, on top of that, you can manage the network ACLs and the router tables for each individual subnet. So you can, in addition to having security groups, on top of that, you can have stateless network ACLs that control what ports and protocols are open between subnets and even out to the public internet. So you have control like that as well. And then you can even, if you want to do IDS or IPS type instances, you want a network choke point that all traffic must flow through, you can use NAT instances on the environment that allow you to go ahead and install an IDS or an IPS component, software component on there, and then use that as a way to control access through more of a trombone, in and then spread out through the environment kind of thing. So you have that level of control if that's necessary or appropriate for your architecture. So obviously, I won't spend a lot of time on this particular slide, but security practices definitely still apply in terms of coding standards. pen testing is totally doable and supported. People often ask, can I do security and pen testing in the environment? Yes, you can. You probably, in fact, we request that you let us know when you're going to do pen testing, because there are obviously protections in place on our own environment that we can go ahead and could potentially, foil any pen testing you might be doing. So you want to let us know so we can sort of flag those instances as under pen test, so you can actually perform your pen test without us interfering, if you will, in any pen testing you want to do. So we definitely allow that in our environment. Obviously, using antivirus software if you want. IDS and IPS type systems, intrusion detection and intrusion prevention systems are definitely supported. You can actually go ahead and run those. And of course, you can obviously aggregate roll logs off these boxes. Go ahead and do analysis on them. All the same kinds of capabilities you'd have in your own operating system that allow you to sort of collect the audit information around what's happening on the environment, and then you can process it later or pass it even to some sort of IDS IPS analysis server as well. And then, of course, we have our own identity access management system for access to the AWS APIs and those resources. And then, of course, you can bring, obviously, your own. As you mentioned earlier, LDAP, Active Directory, all those things run, perfectly fine in the environment. So you could replicate, your existing directory infrastructure in either a read-only or a read-write manner, depending on what you feel is appropriate. And that allows you to tie that into your application on the environment. So you can unify that. So your operating system can actually join a domain, and then, then therefore you have a single entity or a single place where you're managing access to the OS or even the application itself. Right. So a couple of best practices here on key management. We always recommend obviously creating anytime you create an identity and access management user, like somebody who can start and stop servers, you limit obviously you use the principles of least privilege, limit what it can do, trim it down to the least possible amount of API set that it needs. And then of course you never package any of your secret keys in any of your operating systems. Kind of makes sense. Don't leave it out there stuck in the operating system for it potentially being hacked or stolen. We do always recommend key rotation, which we support through the API. So if you have a user, you can decide to essentially create a new secret key for that user, and then as your code changes to roll in this new secret key, you can then deactivate the old one. So you have ability to sort of have two keys working at the same time, migrate your code over, and then shut down the old identity. So you have key rotation capabilities that you can manage. There's also techniques, one example here in terms of how you might pass an application key is on the instance you might keep only a decryption key, and then an IAM user that has access read-only access to a particular bucket. It might be able to read that bucket, and all it can pull down is a file that contains your actual secret key in an encrypted format. You can then use the decryption key stored to decrypt it. Now you have it in memory, so it's only in memory on the box. And then once you retrieve it, you can then use that for making any further API calls. It's one technique customers have used to sort of protect that key and allow them to rotate and encrypt it over time. And then, of course, you can use logging on the bucket to determine who's actually accessed that. So if you have unauthorized access, you'll see that through that environment. So if there's obviously leakage, you'll see that. This is extending your credentials. We talked briefly about that. So you can see, security groups, you can create domain controllers in here and then actually have member servers actually joining those various security groups. Often this is done in the virtual private cloud offering just because the nature of allowing you to control the IP space makes it easier to have a more predictable IP as machines start and stop. It's totally possible in standard EC2 as well. You can create, oftentimes customers will consider creating a read-only domain controller so they can extend their identity without putting it at risk for modification in a cloud-based environment. And then, of course, we actually have a whole white paper around this. So if you're interested in how to do ADFS or single sign-on, we actually wrote a white paper on top of that. And obviously, this deck will be made available. Yes, question?
When you're referring to domain controllers, will any LDAP authentication mechanism substitute? Or
Yes. Yeah, so when we talk about domain controllers, we often use that term, and most people think Active Directory, but it could be LDAP. It could be any kind of standalone or domain controller type product that would run in that environment. Yeah. Mm-hmm. Now, there's some interesting security opportunities that arise when you think about using a virtual private cloud type or AWS type opportunity. So, one is you have the ability, and we talked about this in the earlier session, when a machine seems to be compromised, there's sort of a problem with it, there's a challenge. Seems like somebody might have gotten into a box and you're seeing unexpected behavior, you're having trouble troubleshooting it. You can quickly move that machine. You could stop it. You could move it into a corner. You could leave the drive available, and then you could do some diagnostics on it at a later date by attaching it to another machine to do sort of discovery of what occurred to that environment. So you can bring it out of rotation, quickly shut it down so it's not going to cause any further issues, do some further analysis on it later, while bringing a new machine, a new clean machine into rotation. So the thinking about how to deal with a potentially compromised box can change. You actually can just stop the box, put it in the corner, spin up a new one to replace it so you don't lose that ability to serve customer requests or lose the ability for your application to continue to function, but you then get a machine in the corner that you can then sort of do discovery on and analysis, determine what actually occurred in the machine, do some forensics on top of that box. So it's one nice thing that you get in terms of this kind of an environment. Sometimes people come across odd little bits of log entries. They're like, what's this log entry? This seems odd. I'm not quite sure what this is. And they're like, I wonder how many more of those there are. And then they look at the environment and they realize they have 50 web servers all spewing out logs across many, many days, and they're not sure how much data they're going to have to process even to find the answer to how often something like that occurs or how dangerous it might be. This is where having access to something like Elastic MapReduce, the ability to quickly spin up a on-demand cluster of nodes that will process all of those logs from all those web servers, spit out kind of a heuristic that says, guess what? Turns out this log entry only occurs in 1% of cases. And then maybe you say, well, it's not a big deal, I'll just move on. Or it may turn out that it's actually much more prevalent than you thought, but sampling never told you that. right? Sampling wasn't enough data. So the ability to process the entire set of data, that possibly gigabytes to terabytes to petabytes of logs that you might have, to determine if there are certain types of attacks or certain types of faults in your system occurring, is something that's much easier to do without actually having to pre-purchase a large cluster of nodes to do that kind of analytics, right? Patching is another space where people worry about patching their operating system, always keeping it up to date. Obviously, things like turning on Windows Update to automatically update and reboot your boxes is one option there. Not everyone uses Windows. Another approach is to use much more of a minimal operating system that really is just, let's say it's a bare bones Amazon Linux, which is based on CentOS kind of operating system. And that allows you to then install just a configuration management daemon on there. And so every time you want to bring up a new node, instead of saying, oh, there's a security patch that came out, I know that Amazon's already patched it in the operating system. I'm just going to change my AMI from the current Amazon Linux to the new Amazon Linux, and then my build-up of my environment actually happens dynamically on launch. I can then move forward operating system-wise or test out a new operating system very, very quickly because I've built in this configuration management dynamic build-out model in my application, in my operating system. Question for you? Right. So the question was, what about backwards compatibility in that kind of environment? And that's a great point. You don't have to move forward. So when we roll out a new AMI, obviously you can stay with the old one. It's not like we force you into that new one. This is just one model that allows you to quickly move forward and try it out. In that case, what I would do is I would always do a test case. I would fire up a new node, see how it worked, see if it was taking traffic properly, it looked like it was clean, and then I would consider rolling my environment forward. But yes, it's a great point. Backwards compatibility is something you'd want to check before you sort of did that dynamically. If you've got a high-risk site, as a high-risk application in your data center, you might choose to say, well, I've got this collaboration platform, for example, where there's multiple partners, multiple countries, multiple entities that maybe don't have all the rights to everything I have in my data center. I want to find some place where I can securely host that and give them access to what they need without necessarily worrying about all the other things in my data center they might try and get access to. You could take that application or that component and then run that in a virtual private cloud offering. You could build an IPsec tunnel into it so it still looks like it's local to you, but then you can allow public internet access for them. If they can then get into that environment, they can see only the data in that collaboration platform and not get directly into your data center itself. So you can use it as a way to actually do some partitioning or isolation of environments. Question to back.
Yeah, so in terms of those Amazon-supported AMIs,
yes.
There's a very limited number.
Mm-hmm.
That's the problem, basically finding the audit information, knowing what's in them, and then knowing when something's changed and how it's changed. Is there a site where we can look at it and know that?
Sure. Question was, is there a site where we can find the audit information, what changed in the Amazon Linux AMIs, instance to instance or AMI to AMI? I'll have to show you what we have on that one, and then see if that's good enough. If not, then we'll probably have to have a follow-up conversation about how you can collect that through support tickets and things like that. Yeah. Yeah. No. Okay. Good. Step in the right direction. Yes. Yeah, the other left. Okay, great. Okay. What if I turn this way? All right. So that's definitely another model is to consider as a high-risk application. You can move to a separate data center. You done copying that down? You good? Can I go forward? Okay. So security, obviously, we mentioned it belongs in every layer. There's lots of ways to use some of the features of our platform to actually get this kind of isolation. So one example is you can use multiple AWS accounts. So we don't talk about that much because, obviously you're like, well, why do I want multiple accounts? But you could imagine multiple accounts as a further layer of isolation from a resource access perspective or management perspective. I've got a dev test environment. I've got a production environment. I don't want to worry about my dev test resources somehow badly interacting with my production resources. I'll just use two different accounts. They won't be able to talk to each other because I've kept that isolation automatically, right? I've got, lines of business functions where this line of business shouldn't have access to this line of business infrastructure or security. I can literally use multiple AWS accounts as a way to isolate those. If you need common capabilities, you can enable it if you so choose, but by default, you can also keep them separate. So you can use AWS actual accounts as a way to do some isolation of resources or access. Certainly an interesting model, depending on, and of course, risk levels. High security, applications, those are under this account. Medium and low are under this account. You can keep that side of separation. So even if somebody tries to do something they're not allowed to, they want to be able to see or manage the resources that actually have that application on top of it. Oh, and an important point is that you can get one bill still. You can actually use consolidated billing. to have them all flow back to one master account that pays for everything. So if you just want one master account to pay for it all, but you want a whole bunch of accounts to manage resources, you can have that kind of separation. And of course, there's multiple layers of defense, obviously. From a security group's perspective, that's the network layer. You can block ports below the operating system at the hypervisor layer. We're actually doing that blocking. In standard EC2, you can block inbound traffic. In VPC, you can actually block both inbound and outbound traffic, right? So you actually have two sets of security groups in the VPC, or two sets of rules. Network ACLs, are allowed in the virtual private cloud. So if you want something outside the subnet that actually manages what's even allowed into a particular subnet in the VPC, you can have a stateless, network ACL that controls ports and protocols there as well. You want dedicated instances. People often ask, well, what if I want a single tenant model, where I want to be the only person on that physical host? That's something we offer in the virtual private cloud offering. You can go ahead and decide to enable dedicated instances. So if we put you on a box with somebody else, it will be you, right? So you'll still be multi-tenant, but you will actually end up being on the same physical infrastructure with yourself. No other customer will end up on that same physical infrastructure with you. So if you want that kind of a model, you still want multi-tenancy, but dedication, we do that as well. Obviously, operating system hardwares or firewalls exist, and you can just use them. They pretty much work as is. We've heard of no issues with anything, bringing either the Windows firewall or IP tables or checkpoint, things like that work just fine. So you can add those to your infrastructure and create, obviously, flow-through choke points for that as well. You can have border firewalls in the VPC instance. You can have what's called a NAT instance, and basically every traffic into and out of that subnet will flow through it. You could obviously configure the firewall setups here. Obviously set that up if you want to do something like that in standard EC2. There are third-party solutions around that that allow you to actually have a single entry point to the environment and then flow through to all the subnodes below. It's not something we offer, but it's possible with some manual configurations. VPN in the VPC side of the house, we have a VPN gateway that automatically spun up. You can enable it, and then you can build an IPsec tunnel from your data center directly into a virtual private cloud gateway. You can also set that up in a software way on top of standard EC2 as well. So you have that ability to do VPN tunnels or VPN platforms as well. A common feature that most folks like in their environments is a bastion host. This is a box you might log into to do any kind of management of the remainder of the infrastructure. You would log into that bastion host. Think of it as a bastion host, a jump server. You log into it. That does all your VPN tunnels. It does all your credential checking, and then from there you can jump to the rest of the machines inside of your environment, for example. Obviously, you can enforce that with security groups in the bastion host, and here you have both security groups and network ACLs to work with. And then, of course, in the IDS, IPS space, you would, in the standard EC2, you could install some host intrusion detection products, things like Snort, things like that actually do that kind of work for you at the operating system level. In the virtual private cloud offering, you could do it either on the box or you could do it inside of a NAT instance, which is an entry point for all traffic kind of thing. So a lot of control, a lot of choices to make here, but you can sort of imagine how you can configure and set up all these different setups for you. Yes, question?
One more patching question.
Yeah.
Are there any security alerts that are sent out based on what image you're using?
Yeah, so are there any security alerts sent out based on the image you're using was the question. We do, in some cases, actually alert people if we see certain things that we know are potentially dangerous. Like we've had scenarios where we've seen certain ports that were open and there's known exploits on packages on those ports. And we said, hey, this port's open to the world. You probably shouldn't run it like that, or you should consider relooking at that kind of a thing. No, not necessarily package versions, because we don't know necessarily what's in your operating system. So we have less visibility into exactly what you're running. We can see things maybe from a security group configuration perspective, but we don't know what's sitting inside your OS all that deeply. So this slide is actually a repeat of a slide, just a different look at it, which is kind of your tiered security group model, right? You can SSH in here. You can layer between them. You can allow that kind of control. All the internet traffic is blocked. All your public internet traffic comes through to your EC2 instances and then flows down from an application perspective back and forth, right? So this is just a kind of that tiered security group model we've talked about, and now this is the second time. It's always good to see it again because it's an important point about how you can lock down your network very, very quickly and very, very easily in both the VPC as well as the standard EC2 environment. Patching, you still need to patch. Obviously, patching is popular. You still need to patch. You still own patching. So the minute you build your own AMI and you have your own version, or even when you start an instance, it does not get auto-patched unless you've turned on some sort of operating system feature to do auto-patching. So what that means is that you own any, obviously applying any security fixes or patches that come out. Obviously Windows Update works just fine. So if you're using a Windows operating system, you'll get the alerts on the instance. It'll tell you, hey, there's a security patch available. You can obviously patch it and then reboot it. You can then, from that, build a brand new AMI for yourself, which is up to date, has the latest patches installed. So that's totally possible. And then, of course, there's many other things that people like to use on top. This comes back to that configuration management tool. One model for configuration management is obviously deploy software and configs. Another model is even to use it to patch things. You can use it to upgrade your versions of your application platform. You can use it to upgrade versions of software running on the system. So any patching associated with that could also be deployed as part of a configuration management platform. And here's 4 common ones that are out there. And there's many more. So, monitoring tools. Obviously, monitoring is a key piece from a security perspective, understanding what's going on, what's happening in the environment. I think the quick summary here is that you can take what you have and it will run. Most of the time, I haven't seen any real issues in terms of bringing existing monitoring packages and just dropping them onto the environment and running the operating system. And that's going to do your application and your operating system monitoring for you. And then you can unify that with our CloudWatch data, which actually has all the metrics that we collect from the hypervisor layer and underneath the covers. So now you have 2 sources. So if you're curious, hey, the CloudWatch says something's going on with the box, and my monitoring package says the same thing, you've got actually multiple bits of data that tell you that these things are actually occurring, right? Or if they differ, you realize there's some challenges there in the environment kind of thing. But you have 2 sources of data to pull together. And of course, CloudWatch also supports pumping in your own metrics. So if you want to push your own metrics into the monitoring platform, you can go ahead and push metrics and aggregate them, and then we'll go ahead and display them through our console. You'll see your metrics flow right through. So if you want a unified interface for that as well. And of course, log management comes. A lot of folks want to do forensics or analysis or understand what's happening in the environment. They'll do log rolling and log management for that. There's kind of 2 major approaches we see. One is the distributed approach. It says pump everything to S3 because S3 is a highly scalable file store. So that means that you don't have to worry about how many connections you can have open to it, and you can just pump data into that thing as fast as you want. And then the other approach is to do a more centralized approach. So if you want a unified view and some sort of real time, like, hey, here's what's happening in my environment, I'm going to look at the logs from all my servers in one place, you might unify that and then set up a series of log management servers in the environment that people roll their logs to. And then, of course, analysis is either real time in something like a Splunk, where it's like looking at your logs and analyzing what's happening on your boxes, or obviously, using Elastic MapReduce and doing processing of those logs to determine what's actually occurring in the environment with a little bit of delay there. All right. And so this is security in every layer, pretty much. Obviously, you have your security groups, which are your nice red bars, across all these things. Obviously, Route 53 is our DNS service. The reason why it's interesting from a security perspective, because it's a very highly scalable security DNS service, which allows you to avoid issues of single points of failure or small points of failure around DNS. It's a heavily distributed DNS service. Obviously, auto-scaling can be used both for resizing the environment, but also ensuring a certain footprint is always on. And you can set a minimum on auto-scaling. You say, I always want 1, at least 1, or 4, and we'll make sure that happens. Obviously, your security groups are there. You have your OS firewalls. They're running on the instances. RDS has security groups as well. So if you're running RDS and you're worried about allowing only access to EC2 instances, it supports the same security group infrastructure. And of course, in S3, everything is private by default. You can enable public access if you want to, or you can actually put pre-signed URLs to give somebody access to an object for a temporary period. And then you can have even private distributions in CloudFront, which allow you to rely on people actually having client-side certificates to access the CloudFront distributions. Perfect. Yes.
Is there any automated way to take a security policy and automatically apply it?
So the question was, if you have a spot instance, is there only any automated way to apply a security policy? A spot instance is no different than an on-demand instance or a reserved instance. It's just a different price point. The reason why it differs is that we can shut it off whenever the market price goes above what you're willing to bid. So you would configure a spot instance just like you configure a standard instance. And you would set up the same operating system parameters, firewalls, security configurations, everything else. And when you spin it up, we would spin up your machine image the way you like it. And then the only difference is we could turn it off if the price goes higher than you're willing to bid. But fundamentally, how it operates, the functions, the hardware, it's all the same.
It's not only the security, but spot price. Is there a chart of the spot price?
Is there a spot price? Is there a chart of the spot pricing? Yes, there is on the request a spot instance page. There's a button at the top of the console that says pricing history. You click on it, it will give you a breakdown of spot instance pricing by availability zone by instance type for the last 3 months. Last question. So the question was, if our data center melts, is it the customer's responsibility to have a data center backup recovery site on their own? So if the entire eastern seaboard were to disappear off the map, for example, then yeah, anything you stored in that region would stay in that region. So if you're worried about disaster recovery for that data, and you want to make sure it's available in the case that the eastern seaboard disappears, then yeah, you'd want to copy your backups from S3 US East to US West. You may not want to run a hot site in US West, but you want to make sure your data is copied over there as a minimum. Now, the way to think about what a region represents is it's multiple availability zones, which means it's multiple data centers with multiple power grid providers, multiple floodplains, multiple tier 1 network providers. So we built a lot of high availability into each region to allow you to do HA inside of a region. But yes, if you want to get that last 0.01% of your high availability to where it's 100%, then you'd want to copy backups out of the region so it's safe or at least safe for in case that whole region disappears. Yeah, I would have, if I was setting up it, I have a redundancy between availability zones on that coast. I'd love to take your question, but I have to present over there, and it's like -1 minute ago. So I will catch up in the hallway with you. How about that? All right, after. Thank you.